The workers are faster and stronger than the scouts. They're the stalker army, and they're waiting for the scouts' signal to attack.
It's a very, very successful way to run a large colony and also to be very effective in cooperation, and that includes, of course, hunting. On the Earth, that same social organization is found not only in the insects, but extraordinarily even in the mammals. Now, if this has happened independently on Earth actually a number of times, then there's every reason to think it should occur elsewhere.
The scouts are still doggedly tracking the whales. But they've adopted a risky strategy. The pagoda understory is draped with a lethal veil of tentacles. It's the lair of ambush predators. The scouts must avoid touching anything down here. There will always be the hunter and the hunted. This battle for survival is a major force that has shaped the destiny of life on Earth. On the blue moon, scientists believe it will be no different.
I think there's only one thing that we can say is going to be true of life everywhere. And that one thing is Darwinian evolution. That is the insight that we have from Earth that I think is completely generalizable. Life everywhere will reproduce, mutate, followed by natural selection. That process, I think, is as universal as the laws of gravity and relativity.
Life here is 6 billion years old. It's complex and well established. But how could life ever get started on an alien world like the blue moon? The answer comes from one of the biggest space discoveries in recent years. It happens when stars die. The supernova explosion is so bright it outshines entire galaxies. In its wake, it leaves behind a nebula, a vast cloud of dust and gas tens of light years across. Inside, carbon and all the other elements for life are created.
What's interesting about this dust is that it's rich in organic material. That's the stuff of life out there in space. The biological material in our bodies and in plants and animals are proteins, and those proteins are made out of blocks called amino acids. Well, we see those same types of molecules, amino acids, out there in space. So if the basic building blocks of life are common throughout the galaxy, then why shouldn't life also be common throughout the galaxy?
The discovery that stardust is raining down on planets and seeding them with the ingredients for life is astounding. It could mean that stardust is seeding life right across the universe. And on some worlds, conditions will be right for life to take hold.
In any environment that is broadly similar to the Earth, water, energy, carbon, life will start there as well. So that the story of life could be unfolding in many different locations, independently each time. And as each story of life is written, it'll be a little different than the others.
We think of our own world as being the perfect planet for life. But is it?
The blue moon would in many ways be more habitable, particularly for forests, than the Earth.
Carbon dioxide levels 30 times higher than on Earth will fuel rampant plant growth. The combination of a dense atmosphere and high levels of the greenhouse gas CO2 will act like a blanket, keeping the moon very warm.
You might expect a planet like the blue moon to have smaller temperature contrasts between the equator and the pole.
There will be no polar ice caps and vegetation will carpet its entire landmass.
On the blue moon, we have plants and we also have forests. And amongst the most astonishing are the pagoda trees. Now, these are immense, absolutely gigantic.
They're more than a kilometer high. That's 8 times the height of the tallest trees on Earth. The ceiling of this world is a sea of sky ponds. Each tree has modified its leaves to collect rainwater. And the whole forest is interconnected like one vast superorganism.
So here are forests which are alien indeed.
The trees on Earth could never grow so large.
And the reason for this is effectively that inside the plant there is a set of tubes. It's a sort of conduction system which is responsible for taking the water from the roots up into the sky. And effectively what we see is there's a limit to the size, the height of the column of the water. Now on Blue Moon it's rather different.
The pagodas don't need to draw water up from the ground. They collect it in their sky ponds, and then gravity does the rest. But the weight of the water in the sky ponds could make the tree collapse. The scientists have overcome this by imagining the forest as interconnected. It will give the pagodas enormous strength and stability.
In principle, trees and a forest based on this design could get higher and higher and higher. What could that height be? It could be 500 or even 1,000 meters. It could be easily 10 times higher than trees on Earth.
All life on the Blue Moon revolves around this vast cathedral of pagoda trees. Their sky ponds are a haven for many other aliens. Strange creatures hover above them. Giant kites. They use their tentacles like fishing lines to catch helibugs living in the ponds. The Blue Moon's dense atmosphere is perfect for supporting large creatures. But how is it possible for the kite to hang motionless in the air?
On the Blue Moon, we get more support by pushing on this heavy air than we would by pushing on the lighter air that we've got here on Earth. So this kite, which might need quite a strong wind to get it airborne on Earth, will be taken up into the air by considerably weaker wind on the Blue Moon.
Biomechanists predict a creature with this design could grow up to 5 meters across and still stay airborne.
It's relying on moving wind and an aerofoil effect to keep itself up in the air. So this is going to look in cross-section just like an aeroplane wing. And when there's enough wind around, air passes over top and bottom, creating a pressure difference which lifts the body up, but it's kept in place by a tether, very much like a kite string. And then behind it, we have these tentacles that dangle into the water, just like a jellyfish tentacle, waiting to grab any larvae that it hits.
The kite's fishing grounds are vast. Beneath the pagoda's dense canopy, light from the twin suns rapidly dims. More than a kilometer below is a strange world. No natural light reaches here. In these abyssal depths, life depends on food falling down from above. Glowing scavengers hover in the air,